Hey guys, welcome to today's class. Have fun.
Hi class, so today we'll be talking about sets. What do you understand by sets? Sets are represented as a collection of well-defined objects or elements. A set is represented by a capital letter, while the elements of the set are represented by the small letters. The sets are represented in curly brackets or curly braces. So how am I trying to explain here? We said sets are well-defined objects or elements. For example, furniture is a set. Let us take furniture as an example. Furniture is a set, while tables, chairs, wardrobes, cupboards are elements of a set. Elements of a set means the things that are found in a set. So the elements of a furniture are tables, chairs, and every other thing that can be made using furniture, using wood. So that's what we understand by elements and sets. So elements of a set are things that can be found in a set, and we said sets are represented as a collection of well-defined objects. A set must be well-defined. Like I just gave you an example of a furniture. We can take for instance the number of students in a classroom, or the number of students in a school, or the total number of girls in a classroom, or the total number of guys in a classroom. So that's the definition of a set. A well-defined, a collection, like it's a collection. Every other thing that can be found in it, it's a collection on its own. So I gave us the example of furniture, I gave us the example of a classroom, and I gave us the example of a school. So there are also so many other things that we can classify as a set. So looking at the board, there is an example of a set. Like as you can see, the set there is set A. And what comprises of set A? What are the elements of set A? It's set A comprises of number 1, 2, 3, and 4. And I said something. I said, according to the notes, I said when the elements of a set are always represented by small letters. That is only when we are dealing with letters. For example, now we are having like I said, furniture. We are having furniture as a set. So if we are to count the elements of furniture, which is chair. So this chair, this C will be in small letter. Table, dot dot dot. This is trying to tell you, this dot 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 means it is infinite. Like there are so many things that can be made using wood. There are so many things that can be made and can be classified as furniture. So that's what this dot 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 is, that it is continuous. So this is a set. I said if we are dealing with element of the set are represented in small letters. As you can see, they are all in lower cases. So that's that. So looking back at the example, for this one we are dealing with numbers. So it's still going to be the same thing. There's no lower case or upper case for number. So set A, the set there is A, and the elements of the set are 1, 2, 3, and 4. So the note continues. So the elements that are written in the set are in order and cannot be repeated. That is to say, we are having set A with the elements 1, 2, 3, and 4. So if we have to list the elements of, like if they ask us to list 2 elements of set A, we should list 2 elements. We can't say A equals 1, 1. We can't say A equals number 1 and 1 because this already, we can't repeat this. We are going to write it only once. We can always say A equals 1, 2, or A equals 1, 3, A equals 1, 4, or 2, 3. There's no repetition when dealing with sets. So that's that. So it said they are in order and cannot be repeated. Also, we can write it as I said it. 1 is an element of set A, 2 is an element of set A, 3 is an element of set A, and 4 is an element of set A. So these are the set notations we have. This is not all, but because of the space of the board, I had to just write out 4. So after this one, I'm going to list the others. We have element of, which is the one I showed you. 1 is an element of A, 2 is an element of A, 3 is an element of A, and 4 is an element of A. So we have intersection. We've not got to use intersection, but we are going to use it. When we are using intersection, that means we are dealing with two different sets. For example, if we are given set A and a set B, so if they are asked to find the intersection of both sets, what we'll do is we'll look at the two elements that are common both in set A and in set B. That's when we are talking about intersection. We look at the most common one in between set A and set B. So the common one is the one we'll write out and say A intersection B is equals to so number. I'm going to write an example about that. And union of, this is asked to say if we are dealing with two sets also, a set A and a set B. When we are dealing with union, that means the combination of set A and set B, the combination of the elements in set A and the elements in set B. That's what we understand by union. And universal set, this is trying to tell us that all of the sets, the universal set, that means all of the entire sets. This one we are going to do with this one when we are dealing with, we are going to come across universal sets when we are dealing with Venn diagram, but we are not going there now. So I hope you understand. Sets are represented as a collection of well-defined objects or elements, and I said it was always represented by a capital letter symbol. And the element of the set, the element which is element of A, which is 1, 2, 3, 4. Just imagine is that it was we are dealing with letters, so it's also always represented by small letters. And I said you must always represent your set in curly bracket. The element of your set must always be represented in curly bracket. So there's nothing like you representing your set in block brackets. No, it must always be curly bracket. That denotes a set. So the other type of set we have is, there's another notation that when you see it denotes an empty set. That's when we have two curly brackets, like a curly bracket that is open and closed without an element in it. So that is an empty set. Or when we have that sign, that symbol, that is called an empty set. So when we see, like they said, A minus B, while they are dealing with set, that means they're trying to ask us for the difference between set A and set B. So when you see the minus sign, that is to show you that we are asked to find the difference between two sets. And the P complement there, that P with a line at the top, is called P complement. So P complement, that is all the old sets that are in the universal set that are not in set P. This is when we are dealing with Venn diagrams. We are going there. So P complement is when we are dealing with a set, all the old elements that are outside the set that is not in that set. So we have forms of set. We have the roster form. We have the set B. That what is the roster form? The roster form is a form in which all the old elements of the set are listed. Like I give an example there. I said when we have a set of all natural numbers less than 5, as you can see, the answer there is listed. We have all natural numbers less than 5 are natural numbers start from 0, 1, 2, 3, 4, 5. So we are asking, the question says, what are the natural numbers less than 5? So we'll start listing. Which one is less than 5? We start from 4, 3, 2, 1. So that's what we have there. When you say build that form, this one gives us a form. It says x such that two dots there means such that, and it gives us the property. Look at the example there. It says the set A equals to x. So that's a mistake. Set A. So I made the correct necessary adjustment. So it is the set A equals to s such that s equals to 2n. So they're giving us the property of the set here. So we are looking for x, and they said x is a set, A is a set rather, that equals to x such that s equals to 2n. And they did not stop there. They gave us the way we could find our n2. They said n is an element of natural number. This is n, the n which we have in here, while this one denotes natural number. And I told you this one means element of. So it's saying n is an element of natural numbers, and natural numbers are numbers from 1 to infinity. We can't count them. And they now give us the property of our n also. They've told us that if it's a part of natural number, it's an element of natural number. They also told us the range in which n occupies. And as you can see, n is in between 1 and 4 because of the equality sign there. N is between 1 and 4. That's why we have 2, 4, 6 there. And how did you get the 2, 4, 6? Since we are looking for x, we took our first n, which is 1, and we'll say s is equal to 2 times 1, which is 2. And I told you our n is between the ranges 1, 2, 3, and 4. So we took the next one, which is 2, n equals 2, and we'll put it in our s equals 2n. That is 2 times 2, which is equals to 4. That's how we got our 4 here. We took again from this range the other one, which is 3, and we put it here and say s equals 2 times 3, which is 6. And that's what we got here. And we'll take for the last one, which is 4, which is n equals 2 times 4, which is 8. And that's how we got our 8. And mind you, we are saying this because there's an equal to sign here. This is lesser or equal to, lesser or equal to. That means n is greater or equals to 1 and lesser or equals to 4. So that's what we have here. That's why we could get this answer. So we have types of sets. We have the empty set. Empty set is when there's no element in it, and I'm giving us an empty set here. This is a form of an empty set. This is what we used to denote an empty set. So an empty set is a set in which there are no elements in the set. A singleton set, as I said, as the name implies, it contains just one single element. So it contains one single element. That is a singleton set. So we have a finite set. A finite set is a set in which the elements, they've cleaned most of what I wrote. The elements of the set are finite. That means we know the number, we know the beginning of the set, and we know the end. We know the beginning of the element of the set, and we know the end. That is where it started from and when it's going to stop. That is what we call. I'm going to take one example. That's what we understand by a finite set. While an infinite set is a set in which we only know the beginning, but we don't know the end of it. Like infinity, like the name implies, infinity. We only know the beginning, but we don't know the end. So equal sets are sets that when you have two sets, when set A, let me give us an example. If they say set A equals, set A equals 2, 4, 6, 8, and set B equals 4, 2, 8, 6. So if we look at this now, you see that all the elements of set A are also the same element in set B, just that they are not in the same order. This one started with 2, 4, 6, while this one started 4, 2, 8, 6. So this is saying set A equals set B. That's a form of equal set. And we have subsets, and I said subset. A set is said to be a subset of B. A set A is said to be a subset of B if every element of A is also known as an element of B. It's also an element of B. So let's look at this example that I gave now. Let me just erase out of this our B. So now we say B is a subset of A because all the elements in B is also found in A. So B is a subset of A. So that's that for types of sets. So we are going to take examples on sets, like different examples, just to buttress our point. So we are going to use these questions here to explain everything we'll be saying since about sets. So if you look at the set A, the first one, which is set A, we can see that all the elements of set A are listed. So this will show us that set A is in a what? In a roster form. We talked about roster form. It's a form in which all the elements of the set are listed. While set B is in a set builder form. Set builder form, in which we are given a property and we follow the property. So and set C also is in a form because it is not listed. So this is the set of all prime numbers less than 10. And what are prime numbers? Prime numbers are numbers that are divisible by 1 and themselves. So we are going to list out the answers to set B and C, because without that we have to know what this denotes so that we'll be able to find what we are asked to find here. So I'm going to write it briefly here, but I'm still going to erase it. So set B equals S is such that X is an element of an integer and S is within the range of -1 and 5. So the property says X is, as you can see here, X is greater than -1 and X is less than 5. So what are the numbers that are greater than -1? We have, this is -1, 0, 1, 2, 3, 4, 5, so all these numbers like this are greater than -1. All these whole numbers here are greater than -1. So we're going to list out the numbers that are greater than -1 and less than 5, which are 0, 1, 2, 3, and 4. If there was an equality sign here, we would have included our 5 here. But since there is no equality sign here, so we will not be able to include our 5. So these are the elements of set B. So let us do for set C rather. Set C is all prime numbers that are less than 10. What are prime numbers? I said prime numbers are numbers that are divisible by 1 and itself. So let us list all the prime numbers that are less than 10. We have 2, we have 3, we have we can't add 4. 4 is it can be divided by 2. We have 5. We can't divide 5 by anything. We can't add 6. 6 is not a prime number. We can add 7. Yeah, 7 is a prime number. 8 is not a prime number. 9 is also not a prime number. So we have 2, 3, 5, and 7. 2 is a prime number. 3, 5, 6, 7, 8, 9, 10. Yes, 7. So that's that. So we'll now have to find what we are given here. So A intersection B, for more understanding, I advise you write it out. 2, 3, 4, 5, and 6 intersection our B, which is this 0, 1, 2, 3, 4, 5. No, there's no 5. Okay. So what's the intersection of this and this? The both elements are common, which is 1, 2, 3, 4, 5. Okay. So like I said if our 0 is not included, we could say B is a subset of A. That's if our 0 is not included. And so if our 0 was not included, we would have said this B is a subset of A. Our 0 is included, but it does not matter. So this is the answer for A intersection B, which is this. Okay, sorry, there's no 4 there. I don't know 5 there. I don't know I'm including 5. Okay, I'm sorry. There's no 5 there, so it's just 1, 2, 3, and 4. 1, 3, and 4. 1, 2, 3, and 4. These are the things, the elements that are common. So B union C, I told you have to list them out for better understanding. So we have 0, 1, 2, 3, 4. Yeah. Union C, which is 2, 3, 5, 7. These are elements of an integer. You know what integers are? These are elements of integer. Integer less than X is an element of integer greater than 1, greater than -1, and less than 5. Minus, they are negative integers and they are positive integers. So we have listed it out. B union C, I told you all the elements between the elements in both. We're going to write everything out. That's the meaning of union. It's just like saying the addition of both. So we're going to write it out, which is 0, 1, 2, 3, 4, 5, and 7. So that is our B union C. Okay, so I have to erase this one I wrote down here. So just look at it very well. Set B, which is this, and set C, which is all prime numbers less than 10. Okay, so that was erase it. I have to erase it so that because of the next question. So C minus A, C minus A, set C minus set A. What is set C? Set C is all prime numbers less than 7, less than 10, which is this 2, 3, 5, 7. And minus set A, which is 1, 2, 3, 4, 5, and 6. And I said when we see the difference between two sets, that means elements of set C, I might have to write it out, that is not an element, of A. So if you look at the board, what is an element of C here that is not an element of A? 2 is an element of C and is also an element of A. 3 is an element of C and is also an element of A. 5 is an element of C and is also an element of A. But we have just 7. 7 is an element of C but is not an element of A. So our C minus A, I just showed this one so that you can remember. I wrote this element of C that is not an element of A so you can remember. So let me just erase it so that it does not confuse you. So our C minus A equals 7. And this is a form of a singleton set because it contains just one element. So I hope I've been able to explain all the types of set I gave. Yes, subsets, infinite set. I already gave you an example of an infinite set. Like if I think we solved the question before that said natural numbers. Okay, I explained that one already. I said if the let me just write it out. For example, if we are given B equals all prime numbers, or C equals all prime numbers greater than 10. We were given, so these are the properties of sets we have. We have the commutative property. This is when we say A union B is the same thing as saying B union A, and A intersection B is the same thing as saying B intersection A. So I'm going to use this example here to explain all the properties. So our A equals 1, 2, 3, 4, 5. B equals 4, 5, 6, 3. Okay. So I'm going to use this here to. Okay, let me give us our universal set, which is everything, comprised of everything, both A and B, which is 1, 2, 3, 4, 5, and 6. These are universal sets. 1, 2, 3, 4, 5, and 6. Okay. So let us go for 1, which is the commutative property. This is A union B equals, I will just do 1. I'll do the first one. You can try the second one on your own. So A union B, which is our A union B. This is our A equals 1, 2, 3, 4, 5, and our B equals 4, 5, 6, and 3. So A union B which is equal to B union A equals 1, 2, 3, 4, 5, 6, and this gives us our universal set here. So because I'm managing the board, so I'm going to erase it. When it's full, I'm going to erase it and write something else. So we have the associative property. Associative property. So I said I'm doing the first one too, which is A union. Okay, I have this one. I have to include a C. Okay, I have to include a C for this one. So let me say C equals, I hope you can see it. So I have to include a C. C equals 3, 5, 7. Okay, let me just write that like that. So the associative property says A union B union C equals A union B union C. So like I said, I will do the first one, you will do the second one. I'll do this, you will do this. I will do this, you will do this. I will do this, you will do this, and that's that. So associative property, we are doing this now. So A union. So first do the one in the bracket. B union C equals our B is 4, 5, 6, 3 union 3, 5, 7, which is equals to 3, 4, 5, 6, 7. Okay, so we now say A union B union C, as we are adding the union between this and A. So our A, which is A equals 1, 2, 3, 4, 5 union our BUC, which is this one, union 3, 4, 5, 6, 7. This is going to give us 1, 2, 3, 4, 5, 6, and 7. So that is that for A union into bracket B union C. So if we should do it with this one, we're going to get the same answer. So I'm going to have to wrap off the board and do that for this one. Okay, so we have done for this. So we want to do for this, we want to prove that this equals this, and we have done for this. So associative property. So I'm writing for A union B union C. So A 1, 2, 3, 4, 5 union 5, 4, 5, 6, and 3. So this is giving us, this is A and this is B. This gives us 1, 2, 3, 4, 5, 6. So we let us now add union C to it, which is this one. So A union B equals 1, 2, 3, 4, 5, 6. A union B union C equals 1, 2, 3, 4, 5, 6, and 7. The union of this and our C and this gives us that. So we are going to solve for the associative property. So we want to show that A union B into bracket B union C equals to A union B into bracket, and we now have our union C outside the bracket. So let us solve for A union B. Let us solve for B union C first. I told you for better understanding, it's better we list it out. 4, 5, 6, and 3. Union C, which is 3, 5, and 7, which is equals the union of both, which is 3, 4, 5, 6, and 7. So we now want to add A union this. So we have A union B union C, which is A. I'm listing A out. Sorry, listing A out. Union our B union C, what we got here. 3, 4, 5, 6, 7. So this is going to give us 1, 2, 3, 4, 5, 6, 7. So we have done for this. We've done for this. So we want to do for this. So we'll start by doing A union B, which equals, I told you we list out 1, 2, 3, 4, 5. Union B, which is 4, 5, 6, 3. So the union of both is the addition of everything, all the elements, 4, 5, and 6. So that's that. So we now had A union B union C, which is this, what we got here, which is 1, 2, 3, 4, 5, 6. Union C, which is 3, 5, 7. So we have 1, 2, 3, 4, 5, 6, 7. From here, look at the 2. You can see that this equals this. So truly A union B union C equals A union B union C from here, which equals 1, 2, 3, 4, 5, 6, and 7. Okay, so the next one is the distributive property. So distributive property, like I said, I'll do one, you will try the other for better understanding. Distributive property, which says, so these are distributive property, which says A union into bracket B union C, and we distributed it. We took this A union B union A union C. So that's what we have here. So we want to prove that this will be equals to this. So first, let us find what this is going to give us before we now do this. So B union C, we start with the bracket equals, I think we already did our B union C, so we just copy it. B union C equals 3, 5, 6, and 7. And A union B union C, we've done it also, so we just copy, which is 1, 2, 3, 4, 5, 6, and 7. So the next thing we have to focus, we have even done A union B, and we've not done A union C. So we'll focus more on A union C. So we have done A union B, so we just copy it. A union B equals 1, 2, 3, 4, 5. So let us check for A union C. A union C is, this is A, our A is 1, 2, 3, 4, 5, and our C is 3, 5, 7. So A union C is 1, 2, 3, 4, 5, 7. So now let's do for A union B union A union C. So I told you we're going to list it out. Our A union B is this. This is our A union B. union our A union C, which is this. Our A union B, sorry, we did not include our 6. I'm sorry. A union B, yes, sorry, I made a mistake, yes. This is our A union B. From here, there is 6 there. A union B, there is 6. Okay? So that was included. I'm so sorry for that. So I've included this. These are A union B, union A union C, which is this. 1, 2, 3, 4, 5, 7. So this gives us 1, 2, 3, 4, 5, 6, 7. Which is also the same thing as this. So as you can see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So therefore, A union B union C equals A union B union A union C. So that's that. So you can see it properly. Associative property and associative property and distributive property. So we have, I think we still have like 2 more properties to show. So the next thing we want to solve for is the complement law, and this says A union A complement equals A complement union A. This is the same thing as the associative property we did. A times B is the same thing as B times A. So that's the same thing this is saying. And the other one says, the other property says A intersection A complement equals to an empty set. So let us see if that is true. So I said our A equals 1, 2, 3, 4, 5. Sorry, I just formed the question from my head. Sorry. And our A prime. So let's look at our universal set. A complement says, I already told us about complements. All the elements that are in the universal set, elements that are here, that are not here. So let us look which elements are in the universal set that are not in A. So let us list it out. We have just 5, 6, and 7. So I want to take for this first property, which says A union A prime equals A prime union A complement union A. So A union A prime equals, what's our A? 1, 2, 3, 4, 5 union 5, 6, 7, which equals 1, 2, 3, 4, 5, 6, 7. And A prime union A, the same thing. Union 1, 2, 3, 4, 5, which is equals 1, 2, 3, 4, 5, 6, 7. So we have seen that this equals this. So let us do for the intersection. So we said A equals, for A equals this. So let us do for it. We said that A equals 1, 2, 3, 4, 5. So and our A prime equals what? 5, 6, 7. So the intersection of both, let's check it. The intersection of both equals 1, 2, 3, 4, 5. Intersection 5, 6. I'm sorry, our 5 is not supposed to be included. I'm sorry, I'm making so many mistakes. I just saw that no, it's A prime. I said all elements that are in the universal set are not in A, so we just have 6 and 7. I'm so sorry about that. So it's just 6 and 7. I'm so sorry. Complement of A is just 6 and 7. So I've made the necessary adjustment. I'm so sorry about that. So 6 and 7. So we have A intersection A prime, which is 6 and 7. And if you look at it, what's common between both? Nothing. So we have an empty set, or we denote it by this or this. And so we have proved that this equals this. So the last law we'll be checking today is De Morgan's law, which says A union B complement equals A complement intersection B complement, and A intersection B complement equals A complement union B complement. So we are going to do for this first, and I said we have to do for A union B first. What's our A union B? Our A union B is 1, 2, 3, 4, 5 union B, which is 4, 5, 6, 3. So this gives us 1, 2, 3, 4, 5, and 6. So A union B prime is the total number of elements in the universal set. The elements of the universal set are not in A union B. So let us list the elements of the universal set and then in A union B we have just 7. Yes. So we have a singleton set here. A union B complement is a singleton set. Okay, so now we want to find A prime and B prime. A prime equals 6 and 7, and B prime equals 1, 2, and 7. So we want to find for this, which says A prime intersection B prime equals 6, 7 intersection 1, 2, 7. So what's common between both is 7. We arrive at this. So therefore A union B complement equals A intersection A complement intersection B complement. So I want you guys to try the other one yourself, the other one, which is this. I want to see if you arrive at the same answer. So it's actually very simple. There's nothing much about set. So these are the properties of set. We've seen the associative, we've seen the distributive, we've seen the commutative, and now we've seen the Morgans, and we've seen complements also. So that's that.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.